Welcome to video number 1 of Pre-Calculus, Unit 0, Lesson 2. I know it's confusing. It's just because of the book we're using this year in my in-person classes. If you're joining me just on YouTube in general, thanks for being here. Let us know in the comments what we can help you out with math and with science and with general homeschool stuff and all of those things. We're going to be talking about operations with complex numbers. Hopefully this is review for you and you've seen some of this before, but if not, that's why we do review sections, or at least one of the reasons. So we're going to jump into a couple of different pieces. We're going to do a few examples and all of those kinds of things. So our first thing that we're going to review is complex numbers. And we're going to do this kind of quickly. If you're in my class and we need more time, that's why we have in-person classes and office hours and those things. But if you're not, then you can go back to some of the other courses and some of those notes. So the first thing we're going to look at, hitting wrong buttons. First thing we're going to look at is I. In case you don't remember or don't know, I, in this context of complex numbers, equals the square root of -1. Now, before you learned about this, you know that they told you, or I told you, or whoever, that you can't find the square roots of negative numbers. And that's true when we're talking about a real number answer. But we do have complex numbers here. We're not going to go into the depth of what you can do with complex numbers and all those kind of things. That's kind of, we do talk about that a little bit at the very end of this course and then in other places too. But we need to know how to deal with some of the basics, which is what we're going to talk about today. So let's kind of talk about the four types of complex numbers. So if I equals the square root of 1, you remember or know that if we take I squared, that would be the square root of -1 squared. Now, square and square roots are opposites, right? And in math, opposites cancel. Same thing here. Square and square root cancel out, leaving us with just -1. So I squared equals -1. This is an important one, as we'll see when we do some other examples later on in this video. I squared equaling -1 is one that you need hardcore memorized in your head, because as we simplify stuff, you need to be able to recognize that one very quickly and very easily. So I squared equals -1. But we're going to go through all the little pieces of this puzzle. I cubed. Now, if you remember from operations with exponents and all that kind of stuff from previous courses, hopefully, that if we have like bases multiplied, you add the exponent. So this could turn into I times I squared, because if there's nothing up there, remember that's a 1, so 1 plus 2 is 3. Well, we know that I squared, I'm doing this out of order, and you'll see why in a second. I squared equals -1. Actually, why don't we not do this in order, out of order? Let's keep it in order, because I'm going to have to rewrite it anyway. I equals just I. It equals the square root of 1. Excuse me, the square root of 1. No, it equals the square root of -1. And I squared equals -1. Well, -1 times I, or I times -1 equals -I. So I cubed equals -I. Now you may be noticing a pattern-ish here, right? I'm gonna add this I equals I up here at the top, just to kind of see what's happening. That if we have i's, imaginary numbers, complex numbers, and a problem, we can always boil them down to some version of 1 or -1 or I, right? I to the fourth is kind of going to be the last place that we go, more or less. Well, we'll go to I to the fifth just to make our point. Again, hopefully you've seen this before. If not, this is not that bad. It's a pattern, or as my daughter used to say long time ago, it's a patterned, all those things. I to the fourth. So that would be, if we're operations with exponents, I squared times I squared. Well, we know I squared, going back up here, equals -1. So this would equal -1 times -1. And hopefully that's easy math for you at this point. If you're in pre-cal, -1 times -1 is +1. Now I'm going to go one step further just to make sure. If we have I to the fifth, I'm not going to write it all out. I to the fifth would be I squared times I cubed. I squared is -1. I cubed is negative I. So negative 1 times negative I equals I. I cubed, I to the 6 would be I cubed times I cubed. So negative I times negative I, which would be the same as positive I squared, which would be negative 1. And that's how this pattern goes. It goes, we have 4 parts to this pattern. We have first part is I. Second part is negative 1. Third part is negative I. And the fourth and final part is I to the 4th. If you keep on going, this pattern repeats forever and ever and ever. So if we had I to the 8th, that would equal the same as I to the 4th, right? That would equal positive 1. If we have I to the 7th, that would equal the same as I cubed, which is the same as negative I. Right? And so the type of example we see using this information or the entirety of this information is something kind of like this. We'll call this example 1 on this video. And if we're looking at something like I to the 53rd, and the instruction said something like simplify, right? Kind of put the cart before the horse, but that's okay. No big deal. It's like awfully red complected on this background. Oh, well, it'll be fine. We'll all live. So we need to figure out which one of those 4 possibilities this one fits into. So this is what we do. We look at, and you can do this on the calculator and whatever else, but there's actually a couple of different methods, and if you're following along in the book we're using in this class, in my in-person classes this year, it says another method, but I think this one's the easiest and most straightforward. And so in order to figure out which possibility we do 53 and we divide that by 4. 53 divided by 4 is 13 with a remainder of 1. Now, if you're punching this on your typical calculator, you would end up with 13 point blah, 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 whatever. And then to figure out how many remainder it is, because that's actually the key piece of this puzzle here. We want to know what the remainder is. You could just do 4 times 13, which will give you 52. And then see what's left, right? That's how remainders work. And so the remainder, you may have already figured this out based on that kind of clue/hint that I just gave, is the remainder tells us which one of these is. So our answer here is I, to the 53rd equals I. Because that first possibility, the number 1 possibility, is I, right? So the answer is either going to be I, negative 1, negative I, or 1. Those are the only possible answers to these particular types of problems, right? So let's do one more of this type. We'll call this example 2. I'm going to put it right here because I think it'll fit nice and neat and orderly, easy peasy, lemon squeezy. Let's do example number 2. So example number 2 is going to be I to the negative 18. Okay, so I to the negative 18. We're going to do the same plan, same idea. We're going to take negative 18 and we're going to divide that by 4. And that equals, 4 with or negative 4 if you want to, or negative whatever. You could write that either way. So it equals negative 4 with a remainder of 2, right? So it follows the second one. We think back to our patterns. I squared equals negative 1. So I to the negative 18 equals negative 1. And that's the answer to that problem. So those are easy peasy lemon squeezy. If you've seen them before, then it's really easy. And if you haven't seen them before, it's still pretty easy. Now, there's a few other different problem types that we might see with complex numbers. The instructions on all of these next examples is going to be simplify. Okay. This is example 3. And it is going to be 5 plus negative 3i plus negative 2 plus 4i. Okay. So the way we handle these is we essentially pretend like the I is just any other variable, and we do it the normal way. With one exception, which we'll see in the next example. Excuse me. And we've kind of already talked about it, but we'll hit that in a bit. So if these i's were x's, in this case, since this is a plus, right, we can just drop those parentheses and move on with our life. So this would turn into 5 plus negative 3i minus 2 plus 4i. Then we could combine like terms, right? No big deal. And these also are alike. So the 5 plus negative 2 gives us a 3. And negative 3i plus 4i is positive I. So 3 plus I is the final answer. That's as simple as that one gets. Let's do another one with multiplication in it. So how about 2 minus 3i times 7 minus 4i? All right. Now that looks like a distributive property or a FOIL problem, and that's exactly what it is. That's exactly how we're going to solve it. We're going to distribute. 2 times 7 is 14. 2 times negative 4i is negative 8i. Negative 3i times 7 is negative 21i. And then finally, this is where we get into something that's a little bit different here in a second. Negative 3i, excuse me, negative 3i times negative 4i is positive 12i squared. And that's important because we just learned in a few examples ago and whatever that I squared equals negative 1. So that's going to affect this one. So we're going to deal with combining like terms, and then I'm also going to deal with this as well. Okay, so this 14 is just going to come down. We're not doing anything with it. Negative 8i minus 21i is negative 29i. And then 12 times negative 1 is negative 12. See how that worked? Pretty simple, pretty straightforward. We've got like terms again. We've got 14 and negative 12. We're going to go ahead and combine those. 14 plus negative 12 is 2. And then we bring down the minus 29i. Oh, looking at how long this video was, and I was looking in the wrong place and confused myself. Easy peasy, right? We're going to do one more example and remind us of an interesting word called a conjugate because we don't like square roots in the denominator and i's are square roots. What is this? Example 5? Yes? Yes. Example 5. Let's do a division problem. I believe, if I'm not greatly mistaken, yep, this is it. So, division problem. We're going to do 5 minus 3i divided by 1 minus 2i. Now, the problem with this, as I just alluded to and kind of mumbled on about, is we don't like square roots in the denominator, and that I is a square root. And so in order to get the I out of the denominator, what we need to do is we need to multiply the top and bottom of this fraction times the conjugate. Okay. The conjugate is we take this same thing and we just flip the middle sign. And we'll show you, and you'll get to see through this example what that's actually going to do. So in this case, we're going to multiply times 1 plus 2i on the bottom and the top. 1 plus 2i. We have to do it to the bottom and the top because if the top and bottom match, then it's times 1. And that 1 is the multiplicative identity, which means it's not going to actually change the value of this number at all. Okay, so for the top, we're going to distribute, right? We're going to distribute 5 times 1 is 5. And then 5 times 2i is plus 10i. Oop, that's not a 0. Try again. 10i. And then we're going to take this dude, negative 3i times 1. That's easy peasy because it's just negative 3i. And then finally, last but certainly not least, we have negative 3i times 2i. So we end up with negative 6i squared, right? Then on the bottom, I'm going to go ahead and walk this all the way out. What you're going to notice is that if you're using the FOIL method, the outside and the inside are going to cancel out. Spoiler alert. That's what's going to happen, which will mean there won't be any radicals in the denominator anymore. But let me show you what that looks like. So the denominator, I'm going to use a different color here, I think, because I don't want it to be confusing with the top. So 1 times 1 is 1. And then 1 times 2i is 2i. Now, again, this is one of the ones that's going to drop out here in a minute because I forgot to change the color back. Oh, well, it'll be okay. We'll live with it. Don't stress. Negative 2i times 1 is negative 2i. Oh, now I changed it back. This is really going to mess with some of you. Sorry, not sorry. If you're in my class, you can yell at me about it in class if you want to. If you're not, leave me a comment. Let me know how much it annoys your life. Negative 2i times 2i is negative 4i squared. Okay, now we got to look at our cleanup phase and all of those things. So we've got a like term up here. This and this. We're also going to deal with these squareds, and we're going to combine this one with this one, which you notice 2i minus 2i cancels, which is what I told you was going to happen. I didn't lie to you yet. You never know. It might happen eventually, just not yet. So this one up at the top, we're going to leave the 5i. I'm going to go ahead and put my fraction bar on here to keep myself neat and organized. 10i minus 3i is 7i. This turns into plus 6, right? Because negative 6 times negative 1, which I squared equals, turns into positive 6. On the bottom, what we have left is, I'm going to go ahead and deal with this square down here. We have 1 plus 4, because negative 4 times negative 1 is positive 4, right? All we have left is some like terms. So 5 plus 6, of course, is 11 plus 7i. You notice on these, we always write the real number part first and the imaginary part second. We always do that. Okay. And at the bottom, we have 1 plus 4, which is 5. So that's all we're going to remind you about as far as complex numbers are concerned at this point. We will see more of them when we talk about quadratics. And then if we get that far, when we get it way to the end of the class, we'll see even more with complex numbers. But that is it for now. Thanks for joining us. See you later. Don't forget to like, comment, subscribe, all of those things. Adios.